So welcome to Chapter 6 Bonding Review. So we're going to go over the bond types that you're going to run into. By the end of this, you should be able to recognize metals versus nonmetals. You should be able to recognize weak versus strong nonmetals. And then also the different types of bonds, right? There's 4 main types of bonds that we're going to go over that we've learned in class. And there's also different charge notations to be aware of. All right. First and foremost, let's go over the electronegativity trends. So periodic trends, right? Electronegativity specifically is how much an atom wants electrons from another atom. So for example, fluorine has a very, very high electronegativity. It has 4.0, so it really wants electrons from other atoms. It increases if you look at the numbers going from left to right. So as you go across the period, it increases, and as you go up a group or a family, it also increases. So as you go to the right and up, it increases. So just look at the numbers to verify that. Right, Linus Pauling is a very famous scientist who created this number system. If you want to read more about him, he's actually a really fascinating person. But he won the Nobel Prize, I think, multiple times, at least twice, which is like unheard of. Most people can barely win the Nobel Prize once in their lifetime. But he's the one who created the number system, and it works pretty well to this day. A couple things to point out about electronegativity. The noble gases, so the very last group right here, helium, neon, argon, krypton, xenon, and radon, those don't have any numbers. They are inert. Inert means that they do not react, right? So inert, I'll write that right here. So the noble gases are inert. So they do not react with anything. They like to be by themselves. All right. The other thing I would like to point out is the different colors. So I've color-coded each section on the periodic table. In red, we have our metals. Remember, anything to the left of the staircase, and the staircase is in green right there. Anything to the left of the staircase is a metal. And metals have low electronegativities. So if you look at the red, the highest that we have is down here at like osmium, I think, 2.2. Everything else is lower than that, right? So they have low electronegativities. They don't want electrons. They want to get rid of their electrons. They're cations. They're positively charged. Whereas hydrogen and boron, carbon, all of those in the green, those are going to be your weak nonmetals. Right, so they are your nonmetals, but they don't really want electrons all that much. They'll take them, but if they have to, but not too much. And then your very strong nonmetals are in blue. Right, so your strong nonmetals are nitrogen, oxygen, fluorine, and chlorine. So that's just an overview on the periodic table on how to read and interpret electronegativity. All right, let's look at the types of bonds. So what to watch out for? You need to memorize the nonmetals versus the metals, and you need to memorize the strong nonmetals versus the weak nonmetals. If you have that down, you will forever know what type of bond it is. So if you look at the table right here, if you have a strong nonmetal plus another strong nonmetal, or a weak nonmetal plus another weak nonmetal, if you have that, then you have a nonpolar covalent bond, meaning that they're sharing the electrons equally. Right? So chlorine, this example right here, that's Cl2, and that's your chlorine gas. If you have 2 of the same, or if you have 2 similar ones, 2 strong or 2 weak, they're going to share the electrons equally, right? Chlorine has 17 electrons, the other chlorine has 17 electrons. They're going to share them pretty equally. They're not going to have any charges associated with them. And there's no special notation that you need to worry about. When you have a weak plus a strong nonmetal, you get polar covalent. And so a polar covalent has electrons that are shared unequally, right? So an example of that is hydrogen and chlorine. So that's hydrochloric acid. If you need to go back and review naming acid rules, I would do so. So hydrochloric acid The chlorine has 17 electrons, the hydrogen has 1 electron. So hydrogen is going to be partially positive, right? Hydrogen is also in group 1, so if it was hydrogen by itself, it would be hydrogen plus 1. If it was chlorine by itself, it would be chlorine minus 1. But now they're bonded together, so they no longer have their charges, but they're going to have partial charges. So the little like squiggly, that's a lowercase delta, which is lowercase d in Latin. And it just means that it has a partial positive versus a partial negative charge, right? So chlorine is going to have most of the electrons. It's going to pull it closer to it. Hydrogen won't have as many electrons. And if you look at the periodic table and you look at the numbers, the electronegativity numbers, chlorine has a electronegativity number of 3.0, whereas hydrogen is 2.1, right? So the chlorine is going to want the electrons much, much more than the hydrogen does. Right. The next one to look out for is a metal plus a nonmetal. And when you have a metal plus a nonmetal, that's automatically ionic. You should know immediately what that is, right? Metals are cations. Nonmetals are anions. When you have two ions, right? Ion. Cations are positively charged, right? Positively cation, positively charged. And then anions are negatively charged. When you have two ions, you make an ionic bond, right? It's in the name. So the only notation that you guys need to know for that is the positive symbol and the negative symbol. So when sodium and chlorine come together, that makes sodium chloride, and they transfer electrons. So sodium becomes positive, and chlorine becomes negative. The next one, the last type of bond, is a metal plus a metal. So if it's two elements in red on the previous picture, then that's a metallic bond. Right, so an example is sodium plus another sodium, and electrons are shared around the atoms. The atoms are in a sea of electrons, so to speak. Right, so let's look at some examples. So we have Ag, which is silver. Ag is a metal, right? If you look at the periodic table, it's on the left of the staircase, so it's a metal. The other Ag is also a metal, so when you have two metals, that is a metallic bond. And so there's no special notation that you need to worry about, so you're just going to write Ag is bonded to Ag. All right, if you look at nitrogen and you look at oxygen, you know that that is a strong nonmetal, right? That's in the blue. Oxygen is also a strong nonmetal. And so when you look at if there's two strong nonmetals bound together, that's going to be a nonpolar covalent. And there is no special notation for that, so it's just NO. All right, you have silicon and hydrogen. So silicon, if we go back to the periodic table, is right here. So silicon is in the center in the green, right? So 1.8, and hydrogen is 2.1. So silicon is 1.8, hydrogen is 2.1. Right? They're both weak nonmetals. So weak nonmetal plus another weak nonmetal is going to be another nonpolar covalent. And if you subtract the difference, right? So 2.1 minus 1.8, that gives you a difference of 0.3. And when you have a difference of 0.3, so if it's less than 0.5, then it is a nonpolar covalent, right? So the range, if I remember correctly, if it's less than 0.5, it's nonpolar. If it is in between 0.5 and 1.7, that is polar covalent. And then if it is greater than 1.7, that is ionic. So if you need to know the range, look it up on your notes. And so since it's nonpolar covalent, there's no special notation. So we have silicon bonded to hydrogen. All right, the next one is hydrogen and fluorine. This is a weak nonmetal. and this is a strong nonmetal. So when you have a weak with a strong, you're going to get a polar covalent bond. Right? If you subtract the difference between them, it will also tell you that it is in between 0.5 and 1.7. So let's look at hydrogen and fluorine. So fluorine is 4.0, hydrogen is 2.1. When you subtract that difference, you should get a value that is in between 0.5 and 1.7. And then you know that it will be a polar covalent bond. And so you have hydrogen bonded to a fluorine. And so hydrogen is normally a positive cation, but now it's bonded to another nonmetal, and so it's going to become partially positive. Fluorine is normally a negative anion, but it is bonded to another nonmetal, so it's going to become partially negative. All right, and then the last one, you have a metal plus a nonmetal, and that's going to be ionic, right? You have a cation plus an anion. That's going to be a nonmetal. Right, so you have iron, and iron is going to become positive, and chlorine is going to become negative. Right, and for iron, there's different charges for iron, so I'm just going to put +2 for now. Right, there's iron 2, there's iron 3, so knowing your charges and your ions is very, very important for this unit. Right, I hope this helped. I'll see you guys in class tomorrow.